The plan is for the data to one QCA doc is make it a working document. But it's just here to inform people, but not compress it.
And Dubai.
It's already 5 documents, 5 MRT-related documents.
So we went in the bar.
So when
He could like right up.
we can discuss it afterwards.
Okay.
I'm not saying
I was like,
Oh, here we go again. Nice. Still need someone on Jabber. We still need someone on Jabber. C is going to take note. Hey, Shilendon, you're taking us, right? Guys, we're still looking for scrap. Anyone? Volunteers? Kind of nice. You know, some let's go to yeah, would be great. Or maybe someone running the thing with the draft.
RTGWG developer RTGWG.
Exactly.
We have a playing version.
Right. So when you first advertise,
You're the first.
capacity of 48 or 96 or 128, we would have the bandwidth. In other words, you would say it's capable of doing language switches and decoding whatever, and bandwidth is the available bandwidth in terms of the number of
Sweet.
Pardon? Oh, yeah.
that was just the fundamental disconnect, and so the input. I've explained this over and over and over again, and I gave you finance for that.
The dark SDN has been closed.
Actually, change the text to indicate that.
Yes, sir. Okay. Good morning, everybody. Welcome to the second meeting with Routing Working Group, and we continue.
Yeah, but that was, I mean, yeah, in other words, each abstract.
So I'm going to start out the session by giving an update on the MRT drafts.
Chris, just sorry, we didn't find anyone for Jabber. Volunteers?
do have stars, I believe. Do we have the stars to give out?
Yes.
Okay.
Anyone? Stars?
Thank you.
Thank you, Leslie.
I'll deliver your star later. Thanks. So I'm giving an update on the MRT drafts here in RTGWG. These are the various authors on the 3 drafts in here. So this actually lists all 6 drafts. I'm mainly focusing on the 3 here in RTGWG. So the first listed up there is the applicability to 802.1 QCA. We made, based on the presentation back in Dallas, there was some feedback question related to loop avoidance mechanisms and how 802.1 QCA avoids loops. And so we added some text to this document to explain how 802.1 QCA, the IEEE standard using MRT as a fast reroute mechanism, also applies the 802.1 AQ agreement protocol as an additional loop avoidance mechanism. You have a question for later?
Can you finish the slide?
No, not yet.
Okay,
Not yet.
go through the slides.
Okay, thanks. So also we had some feedback on the architecture draft, and that was to add a section. There's a section in that compares IP LDP fast reroute mechanisms, and we added a section to include topology independent LFA in that comparison. This draft, so the main discussion for this presentation is the algorithm draft. The next slides are on that. And then there's the LDP, OSPF, and ISIS drafts, which are in their appropriate working groups supporting this architecture. And all of these are hosted at GitHub. That is the you can see the most recent versions between the IETF revisions on GitHub and contribute there, or look at the diffs and so on as well. So, Loa?
Loa Anderson. Question on maturity. We have the LDP draft in the MPLS working group. It has been sitting for at least 2 updates without any real changes.
Correct.
So,
correct.
Do you think that it's ready? I think it's mostly dependent on the algorithm draft. So, do you think the algorithm draft is mature enough now for us to start progressing the LDP draft?
So, the algorithm draft we've made some updates to, but any changes to the algorithm draft are not affecting the LDP or OSPF or ISIS drafts at this point.
Okay.
So I'm expecting to progress both the architecture and the algorithm draft within the next few months, and at which time it would be appropriate to move forward with the corresponding LDP, ISIS, and OSPF drafts.
Okay. Can you flag us when it's time to do that?
Yes, I will
Thanks.
definitely do that. So focusing now on the updates which have been made to the algorithm draft, there are several clarifications which came out of another implementation being done, someone reading through the pseudocode and having questions, and there's been pretty active discussion on the mailing list regarding those clarifications. And so that's been an incredibly useful process. Someone coming in pretty much completely new to this area and looking at the existing pseudocode and trying to do an implementation based on that. And so there's some clarifications that came out of that. The main ones are just clarifying the usage of the term root, because there's some ambiguity, because it can mean the GADAG root, the local root, or the SPF root throughout the document. And so that's been clarified a lot. Also, in the pseudocode, there were cases where, in general, we sort of assumed that you would just use the ordered interface, the interface ordering everywhere. However, it's only affects the correctness of the algorithm in certain places. So that could be a potential implementation optimization. So we clarified that in the pseudocode. A fairly significant change that actually affects the algorithm result is handling of parallel links between the same nodes in adding those links to the GADAG. The algorithm now makes all parallel links between blocks, both incoming and outgoing. The previous version of the pseudocode didn't do that. And so this is, I think, a nice simplification. And that also came out of the feedback from Anil. The other clarification in the pseudocode is we just made more explicit and systematic the logic behind the functions for selecting alternates. There was an explanation that I found somewhat difficult to understand, so rewrote it and then created a table that systematically goes through every single case, and then changed the pseudocode to go through that. The end result is identical to the previous pseudocode, but it's just more comprehensible to systematically cover each case. So another major addition to this, it's not a change so much, but an addition, is the inclusion of a Python implementation of the MRT algorithm in the text itself. So we basically followed the pseudocode and did as well an implementation in Python. And it turns out to really read very closely, to read very much like the pseudocode. Ended up having to make it just Python 2.6 and 2.7 compatible. There was a Python, I wanted to do Python 3.0, but there was the compare function does something in a strange way that would have made it less clear. So it could have been done, but for clarity, just stuck with 2.6 and 2.7. And as I said, the actual code's incorporated as text into the draft as a code component. So the actual code, you can either like cut and paste it out of the draft itself, or you can just download it from GitHub. It's in a subdirectory of the directories that are housing the text. And it's written in such a way that you should just be able to download the one.py file, run it, and then it produces text files, the input topology text file, which then provides you with a good example. So I wanted to do that instead of having you have to cut and paste multiple text files into various places and get everything right. So it sort of builds itself out of one file. And then it puts out canonical format for the first the GADAG, and then the red and blue MRT next tops, and also for the alternates. So in a kind of canonical sorted format, so you can then compare that to the output of another implementation. I think it's quite useful because in interop testing for MRT, it's one thing to test a few nodes together, but MRT is very focuses on a whole topology, and so to do really complete testing, it would be difficult to do that with complete interop testing. It would be difficult to do that with a few nodes. And so one way I expect this to be used is for other implementations to generate many topologies, run them through a simulator of their implementation based on their code, and then run the same topology through this code and compare the answers. And that's what we did with our C implementation. So to confirm that, okay, everything is working as expected relative to the pseudocode. So one question then this brings up is, if the Python code looks very much like the pseudocode, there's some extra stuff to make it actually run as a program. but it has the nice feature that it will actually run, whereas pseudocode doesn't run. And so it might make sense to make the Python implementation the actual normative version of the algorithm, as opposed to, as it's currently written in the text, having the pseudocode be the normative version of the algorithm. So I sent out an email on the list regarding that question, and if anyone has feedback here or on the list, I'd appreciate it as to whether or not that makes sense to do. Well, if there are no questions, then I'll turn it back over to Jeff.
David? Thank you, Chris.
Do we give a specific color?
Okay, good morning. I'm David, and the microphone is broken. And this is the destination and source routing update, which is stuff coming in from HomeNet. Since a lot of people are still unaware where this is coming from, is this on auto mode? It's jumping very fast. I think it's jumping itself. Okay. So this has been presented before here. There have been presentations as far back as IETF88, where the use cases for source and destination-based routing have been presented here. We did have 2 drafts in OSPF and ISIS describing the routing protocol layers of this, and they had some overlap in describing what the router should actually do with the packets. So this is the split-off draft that describes router behavior for source and destination-based routing. And all of this is already implemented, so let's go. And this doesn't... Oh. Okay. What we're actually trying to do is the HomeNet scenario where we have separate uplinks. You see here there's 2 internet connections and an IPTV connection, and the ISPs are doing PCP38 filtering. So they will only accept packets from us if they have the source address that they assign to us. So for any packet that's coming from the bottom here, we need to choose the right exit. And to do that, the solution HomeNet is going with is looking at the source address and routing in addition to the destination address. Next, please. And this has exactly like this been presented before. We did drop the generic approach of trying to add a registry for lookups on the routing system. So the previous draft had a very, well, generic IANA registry actually to order things. We completely dropped that. And we are simply adding a source lookup in the routing, in the per packet lookup after the destination. Now, next, please. This is described here. So what the spec says is you do the destination lookup on a route, on a packet. You find the route with the best destination match, and you look at the sources for various routes that have the same destination prefix. So the lookup on the source address on the packet happens after the destination lookup. However, it's one integral lookup process. So essentially, this is added in the sorting that you do on the routes. Normally you start with the most specific route, go down to less specific route. Now you can have more than one route with the same destination prefix, but with different source prefixes. Next, please. We do say that if you don't find a match on the destination, that you should continue to less specific destinations. The reason we do that is if you have one ISP that is announcing some more specific destination prefix for their sources, we still want to be able to use the default exit on packets that have the source address from another ISP. So that would break if we wouldn't proceed to less specific destination prefixes. Next, please. This is a rough diagram of what this is actually supposed to look like. So you can see there's 2 routes that have the same destination prefix on top. So both of those match the packet's destination address. However, you can see on the right there's a source prefix specified, and none of the top two actually matches the packet that we are trying to route here. So from 2 to 3, the lookup process moves to a less specific destination prefix. And on route number 3, the source prefix still isn't a match, so we move one further. And on the 4th route on the slide, the source and destination prefix are a match. So this is the most specific route that matches this packet. Next, please. If we want to abort the lookup process after going through that destination prefix, you need to explicitly add an unreachable route. So, I mean, that's perfectly fine. If you want that behavior in the system, the user should specify or configure that, and then you can add that route, and you can get to that behavior. So, it's not that it's not possible to get to that behavior. It's just that the draft says that if you don't have that route number 3, you're not allowed to do that. Next, please. We did look at, well, since this is coming from HomeNet, we have a very homogeneous environment there. This draft, of course, is moving out of HomeNet because we're trying to specify the general behavior of a router. So we looked at one of them trying to handle recursive routes. So there's an open question which the draft doesn't answer yet. If you have a recursive route whose next hop matches a source and destination route, what exactly do we do? This is given here as an example. The top route is trying to be resolved through the ABCD next hop here. And for ABCD, we have 2 different routes with 2 different source prefixes. So what exactly is the recursively resolved route? There are different possibilities here. We can ignore source and destination routes. We can try and match them to each other, so we only use source and destination routes for recursive routes that have the same source prefix. Or we can try and duplicate the route to be resolved recursively and install multiple routes with different source prefixes. However, that would result in more routes to actually be installed. On this, I would very much appreciate feedback, because this is a topic that is relevant if you try to mix this with other features like, I guess, most relevant for BGP and static routes that are trying to use a recursive route resolution. Next, please. There are 2 other interfacing concerns that are mostly clear, and I think there's not much need for discussion here. So one of them is Unicast RPF checks. So you can do them by just flipping source and destination. The draft doesn't make this mandatory, so if your system only matches the route's source against the route's, the packet's source against the route's destination, that's fine too. Although you have to match all routes then, regardless of the source prefix. Multicast RPF lookups are another topic there. So in that case, it's simply that source and destination routing isn't applicable, because on a multicast RPF lookup, we only have the sender address that we are trying to get toward for the multicast path. So we only ever have one address, and we can only really look up on the destination, which is the sender in this case. So the draft simply says that source and destination routes are not applicable to multicast RPF lookups. Of course, you're supposed to use a separate multicast topology there to make that work properly, but that's outside of the draft, really. And next, please.
I think you mean unicast address of the multicast sender here.
Yes. Well, yeah. Sender address. Right. So this is the quick run through source and destination based routing. HomeNet has been running with this for, I don't know, 2 years or so now. So the HomeNet working group is really pretty much set on trying to adopt this as routing paradigm to work with multiple ISPs properly. So I'm really trying to get this adopted in this working group so we can get the routing system bits independent of HomeNet properly specified and written down. I do actually have seen personally use cases of this outside of HomeNet. So that was a scenario with multiple BGP uplinks where they were trying to make them selectively available to different users based on their prefix. So I don't think this is really only HomeNet, although the uses outside of HomeNet may not be that common. Either way, I would really appreciate feedback, and I'm trying to get this adopted as a working group document.
Providing a little context in terms of, say, IETF process. HomeNet has determined they need this. However, it's not within their charter, and it would appear to be within the charter of the routing working group. And so we're planning to issue a call for adoption for this draft within the next few weeks. So it would be good to get the expertise of this group to really look at this.
Thank you. No questions?
One question from my side. I think it would be really good to see deterministic behavior for recursive routes, so type breaking in a way.
Yeah. So we do need to decide on one method to do recursive routes in this context.
And document. Nitish?
Good morning, everyone. So we are here to present a draft on VRRP BFD integration. So what we want to do is detect the failures in VRRP in a much faster rate using BFD. So these are the authors, and I am Nitish. So VRRP in its default rate detects a failure in about 3 seconds. So it has a hello timer of 1 second, and then it can detect a failure in around 3 seconds. But what we are looking for is a faster failure detection in VRRP, which can be achieved if VRRP is interfaced with BFD. And to interface with BFD, what happens in VRRP is only the master routers send the advert packets. But what BFD requires is both the peers to know or initiate the session for the BFD session to be initiated. So as I said, there are limitations in VRP where only the master router sends out the advert packets. So the master router does not know about the backups in the network, and as well the other backups do not know about the backups that are present. So that's a challenge that is currently there in VRP. So what we are proposing is a peer learning mode. In this case, what can happen is the backup routers can generate a new advertisement that we are proposing is as a backup advertisement. So when these advertisements are generated, the VRP master can know about its backups, as well as the other backups can know what are the backups that are present in the network. And then possibly they can determine which is the most critical backup after the master that is present, and we can form a BFD session either in a mesh mode, or we can form BFD session with the most critical backup that is present in the network. This is something which is right now missing in VRRP, where only the master router sends out the advert packets, and other peers know only about the master. So this is an example of a typical VRP network where you have 3 routers, 4 routers. Here we are saying that peer 1 has a priority of 200, peer 2 and peer 3. Now they can, if they start sending the backup advertisements, they can form the peer table as shown. And it is not mandatory that we form a BFD session with all the peers in a mesh mode, but I will come to why we are proposing that or recommending it. So what we are saying is you can at least form the BFD session between the most critical backup and be able to detect the VRP failover faster with BFD. And we also have an operational consideration in case there is a peer which does not support BFD. We are saying that you configure that with the least priority, so that is the gateway of the last resort. So some operational considerations are you can remove a backup from the peer table in case you don't hear from the backup in around 3 times the advert interval. as I said, VRP routers not supporting this feature should be configured with the least priority and should be only become the master if all other routers fail. And this proposal is coming only, let's say VRP is implemented in a control plane or a plane which does not scale that well with the faster timers. Rather, it is if BFD is implemented in the line cards and VRP is implemented in the supervisor modules, which can be a bit slow. That is where this particular proposal should be used. And we are also saying that the BFD sessions that are getting created can be shared between with other protocols which are tracking the same peer. There is a consideration that we can also go for multi-point BFD rather than using the point-to-point BFD sessions. But there are some consideration with multi-point BFD why we don't want to recommend that. First of all, the thing with multi-point BFD is only the head decides the rate of the transmission. The tails do not decide the rate of transmission. And there's another problem that is inherent with the multi-point BFD or a multicast sort of a network is it is going to get flooded all over the LAN. And it can go to, let's say, the host which are not even interested in the BFD packets that are coming. And there's another consideration that can happen is, let's say, if we have a VXLAN network where VRP will be typically deployed in one of the VTEPs, and there if we generate VFD packets at a higher rate, they can get carried over the overlay to all the VTEPs in the network, and it can create a storm. So that's where we are saying it is better to use a unicast BFD rather than doing a multi-point BFD. And in that case, what happens is if you add a VTEP, then the core network has to replicate that to the new VTEP that is getting added. So it can get multiplied as you go and add more and more VTEPs. So that's a consideration why we want to propose point-to-point. There are some scalability considerations that we are also putting out. The backup adverts need not generate the packet at the rate at which the VRP master generates. It can always once they know that their backup can generate at a lower pace. And since we are going to detect the master failure with BFD anyway, so we are going to recommend that you have your, in general, VRP timer itself at a slower rate. Need not have it at the fast rate of default 1 second. It can reduce to, let's say, a 3 second or something like that. So it can even help in having more VRP routers in the supervisor. And we are saying, as I already said, that we can have less number of BFD sessions only with the most critical backup. But why we are saying that we can also have a mesh mode, because if there is a master failover, we don't want the backup to initiate or start bootstrapping the BFD session at that time. Rather, it can have the BFD session open, and then later on, when it knows that it is not the most critical backup, it can always control the RX interval from the master to be low, and then when it becomes the most preferred backup, it can boost up that, or it can track the master in a bit more faster fashion. So yeah, that's all I had, and we are right now trying to get feedback from the working group. And we have also forwarded this to the BFD working group, and we have got a lot of comments from Jeff. Thanks for that. So are there any questions?
Santosh from Juniper. See, you are trying to form a peer table and all the routers, right? So how do you ensure that they are all consistent across all the backups are consistent? What if the most preferred or the most highest priority router itself doesn't have a table properly updated? So do you handle those cases? If so,
so that particular preferred backup will know what is the master, and it will act only if the master goes down.
Yeah. So my question is the highest priority knows that it is it doesn't know that it's an highest priority because its table is not updated properly. But whereas the other priority or the lowest priority routers have been updated with the peer table.
I mean, we are assuming that the peer tables are formed correctly.
What if you have an inconsistency?
Yeah, so in that case, what can happen is if let's say it becomes a master, then VRP itself will take care of the other master coming in, and then it can get resolved from VRP itself.
Okay, so maybe you might want to highlight this as in the draft.
Sure.
Jeff has. I think part of what Santosh is concerned about is that if the rate is going to be based on what each system thinks is master backup, you have to make sure that the systems that are in a partition state can allow for the faster rate for the partitioned master to be able to be high.
Sure. I think we had kind of discussed that in the breakfast session also.
Thank you, Nitish.
Thank you.
Go ahead.
Thank you.
This has been mentioned that point-to-multipoint BFD is one of the possible solutions. The question here that we have first, oops, that doesn't look, okay, interesting. Yes. Okay, I think I still remember. So their version 3 allows for 10 milliseconds, and as been stated, there are some challenges in support of this aggressive rate by their hardware, and because of that, there is interest of using detection something else, and BFD certainly comes to mind because BFD presents continuity check, 5880 defined point-to-point, but now we have multi-point document that been revived and progressing very nicely, and it defines two modes for the monitoring in tails and active tails. I think we believe that for the VRRP case, just base multi-point is the most applicable, and so it in the BFD document it specifies that it changes their demultiplexing and creation of their multi-point tail session. So the demultiplexing is done by the source address, and if tail doesn't find their session with their my discriminator and multi-source source address in its table, then it creates new multi-point tail session, because obviously their your discriminator always will be 0. So it very nicely for creation of dynamic sessions, and at the same time, so in a multi-point, because there is no negotiation of discriminators, the PF session process is eliminated. So how it might work? The master router creates a multi-point head type session and starts sending packets on their LAN using one of the IP addresses associated with this VRRD as a source IP address. All backup routers, they've been provisioned with this set of IP addresses associated with VRRD as well, so they can demultiplex these packets. And since arrival of the first packet will trigger creation of multi-point tail session, then they can continue demultiplexing based on combination of source address and my discriminator. So there will be just one session created. And then tail will monitor well-being on the master. So once master goes down, they start election process. based on a protocol, but once master elected, so the new master starts new point-to-multipoint BFD session, and then that continues. We welcome comments, and so we present. We are submitting this as informational document to the BFD working group.
So Jeff, this is partially towards you, and also Nitish's presentation as well. VRP obviously is gaining traction, largely through data center type cases. Again, so the thing to remember for both the Unicast and also for the point-to-multipoint is it's ideal that the BFD session try to follow the forwarding plane of what you're trying to protect, and VRRP being multicast, that's potentially a better application for it. But Nitish also has the good point that multicast in some environments may lead to a lot of interesting problems in terms of overwhelming resources. So for your application, it may make actual good sense. But I'll also remind you that part of the reason why the network at IETF is having unfortunate problems right now is because multicast packet replication at our access points is having weird problems despite the fact that the protocol is doing exactly what it's supposed to.
Yeah, it's a very valid point, and before the meeting we talked about it. There are a couple things. First, it's a property of VRRP. And what I suggested is just we need to document it as informational document stating that aggressive timers VRRP will expose you to this problem. And then suggest that in certain environments, probably point-to-point BFD for the faster detection might be a better solution. In some other environments, either you can use aggressive timers from VRRP, or you can use point-to-multipoint BFD.
So two possibilities spring to my mind, which is some exploration of doing the BFD session using a linked local multicast. Something actually has scope that only lives on the link that may actually address some of the flooding issues. The second possibility is that we probably should consider both cases. Both cases have generalized merit, and it may make sense to actually merge the drafts, because the mode actually may make sense depending on a specific implementation and a specific tunneling type.
Well, yes, we certainly, I agree that merge of the drafts, especially adding it with this note of pointing to inherent problem of VRRP protocol is appropriate. I think that actually it's a very good suggestion, because in case of IPv6, we can do even better. Thank you.
Thank you, Greg. Larry?
All right. Hi. I'm Larry Krieger. So I'm here. You may notice the draft has SFC in it, and I'll get to that at the end to talk about doing UDP overlay for NSH. So since this isn't SFC working group, a quick background on what NSH is. It's a header. It's been adopted in SFC. Its job is to carry metadata across a service function overlay, and it also carries information allowed to be steered through a service graph as well. So it has both options for fixed metadata and variable length metadata. It has it's extensible, has optional TLV mechanisms, and it has a next protocol field itself, which can carry IPv4, or v6, or Ethernet, or whatever else you would want, I guess, in the future. So the thing about NSH is that it's transport independent. So you need to transport it over something, and that's what this draft is about. So in NSH draft itself, it gives examples of how you could transport it. It says you can do it over GRE, you could do it over VXLAN GPE, which note happens to run over UDP as well. Or you could do it directly over Ethernet if you don't need to cross a router. But it doesn't say anything about carrying it over UDP. So that's what this is for. So basically, you have, does it have a laser pointer on it?
Yeah, in the middle.
Okay. So the source port, you can use the UDP source port trick and do a hash of the headers in the payload to try to keep all the flows take the same order through the network, right? And that way you can get entropy into it. It uses right now in the draft 6633, which is assigned to the Cisco vPath services overlay. But we can also ask IANA for a new port instead of reassigning it. And I think that's probably what we would do. And yeah, so why UDP? So you could use GRE, but then you don't have the entropy trick, since most routers don't look at GRE key fields or anything. You can carry it over VXLAN GPE, and that also gets it over UDP, but then you'll end up with an extra 8 bytes overhead that you don't necessarily need. The main thing in VXLAN GPE is the VXLAN, the virtual network ID, so that either there are many applications that don't need it, right? It's not relevant. Or if you did want to carry some kind of a tenant network ID, you could actually carry that inside the metadata. Sorry, Jeff. That wasn't the laser button. Yeah, so you could also carry that virtual network ID inside the metadata itself. If it's a 24-bit one, that would only use 3 bytes instead of the full 8 bytes of the VXLAN GPE header. Okay, so why am I here talking about this? So we intend we'd like this draft to be a standard draft. It is related directly to SFC, as does in the name of the draft. However, SFC is not chartered specifically to handle transports, and in the current workgroup milestone items, it's not listed as anything. So Jeff graciously allowed me to come here and said, well, you can present here, and then we will dispatch it. So looking for guidance, Aaliyah.
Aaliyah Atlas. So the complexity of this draft is not the details of how you stick an NSH packet into UDP. The complexity is, in my opinion, around well, you need congestion control stuff, but you know that already, is around how it's going to interact with the security assumptions that are tied into SFC, because UDP being able to stick an NSH packet into UDP makes security attacks a lot more simple. So, that's the type of consideration that needs to be thought about and has to be thought about in the context of SFC. I'm planning, as you know, on talking to the SFC chairs. I think that if we need to tweak the charter slightly, that's appropriate to do. I don't think it's going to get the right type of focused discussion on nailing down the security considerations in a working group that isn't fully knowledgeable about SFC.
I agree. Yeah, I think it belongs in SFC.
So you're going to the updated chapter, and next time it's going to be in SFC, correct? Thank you.
Great. Thank you.
Thank you, Larry. Bruno?
Hello. Hello. I'm going to talk about, to give an update about the work on SPF delay. So there are two drafts. First one is a problem statement about the increased microgroups when you have a different implementation of SPF delays. And the second one is the solution, well, a solution. Okay, so regarding the problem statement, since DAS, the draft has been adopted as a working document. And then a month ago, we published an update. The main changes are we have new co-authors, Martin from Dutch Telecom and myself from Orange. We had some editorial change, in particular in terms of diagrams to improve the readability. It's not perfect, but it should be better. We have also improved the reference to earlier work on microgroups, in particular OFIB. But in overall, there is no technical change. This is a problem statement, and in summary, having a standard SPF delay algorithm has the best benefit to cost ratio. So let's move to the second draft. Again, it has been accepted as a working document, and we have published an update after. In terms of change, we have new co-authors, Hannes, Essie, Pierre, and Stefan. There has been many editorials improvements in terms of grammar, clarity, and technical accuracy. I'll come back to this. We should have addressed all the comments received, both on the mailing list and on private. So if we missed your comments, please come back. In particular, we addressed the comment from Mike from the routing directorate, which was a very good set of comments. And finally, we added a paragraph to explicitly states that the document is not going to propose default values on purpose, because we believe the default are very implementation, requirement, and network dependent, so they may change over time. So no default value, it's really up to the implementation, but the value must be configurable, otherwise you may still have interrupt issues. So this is defined in a new section, which is parameters. So coming back to technical accuracy, we had some discussion about the terminology SPF, which is used by all implementation, but still some people find it loosely defined and maybe implementation specific. So typical case is when your IP prefix change, what type of computation do you do? Do you call it SPF or PRC? So given it was not clear, we decided to change the term to routing table computation, which is actually the term used by OSPF v2. So it's not a new term, it's aligned with OSPF v2. And we gave a definition, which is a routing computation of the routing table by the IGP using the IGP LSDB. No distinction is made between the type of computation performed, such as full SPF, incremental SPF, or PRC, and the type of computation is a local consideration. So it's a routing computation performed by the IGP. So hopefully we'll find the term more clear, or not, we'll see. Next, to have the best algorithm, we need to define the goals. So the first goal of the document is to have one standardized algorithm. So far so good, we have a working document. And then we try to have the best algorithm as possible. And for this, we need to define what the goals are. So it would be good to review those goals. They are specified in the section 2, which is high-level goals. It's a very short paragraph, a third of a page. It should be easy to read, and it's important because it will impact the choice made on the algorithm. In the end, the algorithm may not be optimal for your specific case, because optimal is very requirement dependent, dependent of the behavior of your links and equipment, independent of your network topology. Also, if we really want optimal algorithm on parameters, we will need to run simulations based on data, on past data, and it would be only a past data, so it will not represent the future. And the goal is to protect from the future. So it will never be optimal for specific case. So in the current text, we choose to prefer simplicity on robustness over trying to be optimal for corner cases. So in terms of next steps, now it's probably a good time to review the document. In priority, if you could review the high-level goals. Again, it's short, and it's important to drive the definition of the algorithm. And if you have more time, it would be so good to review the algorithm, which is a bit longer, 3 pages, and a bit less easy to read. It's an algorithm. So that's all for me. Any comment? So basically, it's a call to review the document. Thank you for the time.
Thank you, Bruno. So personally, I'm very happy with updates. The document has become much more readable, coherent, and very good progress.
So Shraddha, I think you're up next.
Some virtual multi-instance.
This is the pointer. Which one is the pointer? And this is the next page.
Turn it around now.
Good morning, everyone. I'm Shraddha from Juniper, talking about the virtual multi-instance. So the agenda we have today is the problem statement. We'll go over the motivations for the solution itself, and the solution applied to some particular topologies like hub and spoke and ring topologies. And we will go over protocol procedures for this solution and then the advantages. So this is a diagram of the typical service provider network with core network and access and metro network. So this problem is very specific to ISIS. All the edge devices, as you can see, are in level 1. So there are router devices, non-router devices, and CPEs as well. So they all connect to the same L1, L2 router, which connects them to the core. So typically, the customer devices are not very well maintained for power cycles. There could be more power cycle failures or device failures, and these kind of events cause repeated SPFs and the flooding into the entire L1 domain. So some of the non-router devices, which are low-end devices, are not capable of excessive flooding, or they're not capable of repeated SPF computations. So this brings in a scalability problem. So one of the solutions for this problem could be to deploy a separate L1, L2 router for each of these kind of devices, like separate out the routers, connect them via one L1, L2 to the core, or separate out the non-router devices and then put them on different L1, L2 into the core, but that's not feasible most of the times in the same geographical area to deploy multiple L1, L2 routers. So this is another problem typically seen in the IPsec VPN kind of deployments, where the branch offices connect to the head office. There could be hundreds and thousands of spoke nodes connecting to the hub. So link state protocol are not very well suited for this, because link state protocols need to flood the entire link information into all the devices that belong to a particular area. So this causes large LSTB size and unnecessary flooding. So one of the possible solutions in OSPF probably is to put each of these spokes into different area, but that's not typically suited because typical IPsec VPN deployments are zero-touch hubs, so they are plug-and-play kind of thing. So if you want to add a spoke, you just go and configure the spoke and not really the hub. So the multi-area would require different configuration, so that's not very well suited for this problem. So another problem seen typically is in ISIS for ring topologies. So again, multiple rings connecting via same L1, L2 routers into the core. So what happens is all these rings are in the same L1 domain. So any change in any ring causes flooding all across all the rings. And also it causes large LSTB size to be maintained across all the ring nodes. So one of the solutions could be flooding scope, RFC, that's already an RFC in ISIS working group, but the issue with this is it needs to be implemented by both the ends. So sometimes which is not feasible. So the motivation for the solution we have is ease of configuration. So with minimal configuration, we should be able to provide a solution. Partial deployment, that is, you should not have a requirement of all the nodes in the network getting upgraded with the solution. And then support some common topologies like hub and spoke and ring, which are very commonly deployed. So the solution that we have come up with is separating each of the spoke or ring into a separate virtual instance. A multi-instance concept is not new, it's always been existing. What we're trying to do is making it dynamic so that you don't have to configure each of them. We have taken some common topologies and we have defined rules how each virtual instance get configured. And then we have some protocol rules by default, what gets redistributed into what, so that you don't have to do configurations for each of them. And then we also, the solution also does not need software upgrade on all of the nodes. It just needs software upgrade on the hubs, and the spokes may run standard software. So the solution for hub and spoke topology, so each spoke is categorized into a separate virtual multi-instance. So when a message is received from a spoke, based on the source from which IGP peer it is received, the source router ID and destination router ID, it's categorized into a separate IGP instance. The solution requires that you configure on the link that this link is going to have a virtual multi-instance, and then it's going to be a hub and spoke topology. So those are the only configurations required. So, the hub generates separate router LSAs or LSP for each of these spokes, for each of the virtual multi-instance, and it runs a separate SPF for each of the virtual multi-instance. And there are redistribution and preference rules defined for the virtual multi-instances by default, how the routes are redistributed and how the route preference, for example, the routes from this virtual multi-instance have less preference than compared to the routes from the default instance. So in the draft, we've also addressed the case of a spoke connecting to multiple hubs, how it's going to be handled, or when a spoke has multiple links, it connects via multiple links to the hub. So how the virtual instances are defined and how the redistribution rules need to be followed. So this is the ring topology. So for a ring topology, We have two cases wherein you have all the ring nodes connecting to one single hub. I mean, multiple ring nodes connecting to one hub. And there's another case of this typical case is the ring nodes connecting to two different hubs, and then there is a hub-to-hub link which joins the ring. So in this case, the area address of the this problem is very typical for ISIS. In OSPF, it can be easily solved by configuring, putting the rings into separate areas. So this is more applicable to ISIS. So in this case, the nodes belonging to the ring are separated into virtual instance based on the area address. And then, so in some solutions like some deployments which have remote LFA, it's necessary that the entire ring is visible to all the ring nodes for remote LFA FIR mechanisms to work. So for that reason, the link between the hubs needs to be visible to all the ring nodes. So typically this link between the hubs belongs to default instance. It does not belong to virtual multi-instance because we don't want to flood on that link. So if you do so, it would go to all other rings, and then it would cause problems. So typically a hub-to-hub link belongs to default instance. But in case of ring topologies, we advertise this hub-to-hub link into the virtual multi-instances. So it's kind of leaking the link into the virtual multi-instances. There's no flooding that happens on the link, but then the link gets added into the LSP of the hub, which is generated for every virtual multi-instance. So one more typical topology in IPsec VPN deployments is the dynamic shortcut tunnels. So when there is a lot of traffic to be sent from one spoke to the other, there are some new developments in IPsec domain wherein you could establish a shortcut from the spoke to spoke so that your traffic does not go via the hub. So these are kind of dynamic tunnels. They come up and they go down dynamically. So this is actually this causes a lot of scalability issues for the OSPF, because the moment the dynamic tunnel comes up, you need to flood it all across to thousands of spokes, and then when it goes down, you again need to reflood. And since this is dynamic activity, it's a continuous activity, and it causes severe flooding issues. So the solution we are proposing for this is to upgrade the spokes with the virtual multi-instance solution, and then put the spoke-to-spoke connection into a virtual multi-instance, so that once this link belongs to virtual multi-instance, it need not be flooded into all other instances, and then it remains local to the spoke-to-spoke connection. So we have different redistribution rules for dynamic tunnel topology, because it's different from the normal virtual multi-instance, because we can see the redistribution rules. So why we want to make it a standard? Because there are no protocol extensions as such, no change in the protocol messages, but we still want it to be a standardization, because there are some behaviors, default behaviors that we want to define for the solution. So for the solution to work, these rules need to be followed. So one is the identification of virtual instance or area. It's based on topology. So if it's a hub and spoke topology, then it's going to be source router ID and destination router ID of the IGP peer. So there's going to be separate SPF for each instance. And there are redistribution rules, such as from the default route is always advertised into the virtual instance. And then from the virtual instance, the routes are always leaked into the default instance, and they may be summarized when they are leaked. And by default, the routes from the hub should never be leaked into the virtual instance. They could be done so using policies. And in case of ring topologies, we can leak links, hub-to-hub links into the ring virtual multi-instance. So the advantages, it provides an excellent scaling properties for IGPs, minimum configuration overhead. It's backward compatible because spoke router or ring nodes do not require software upgrade.
Greg Mirsky, Ericsson. So you propose it to be applicable to ISIS and OSPF.
Yes.
For the hub and spoke, so had you considered a stub area, non-stub area, or NBMA type of interface on the hub?
Yes, yes. So typically it's a P2MP interface that's deployed on the hub, right?
NBMA?
Yes, NBMA as well.
So why NBMA is not good in a stub area? You don't have flooding then.
So you need to configure. I mean, it's supposed to be zero touch hub, right? I mean,
make NBMA on your spokes default.
But then any change in the spoke, it's supposed to get flooded, right?
No, stub area.
AC Lindum, Cisco. The thing about you could do an NSSA per site, but operators don't want thousands of areas, and most implementations don't expect that, so they have a lot of linear walks for all the areas and things. So it doesn't work very well. An operator doesn't want to have, like in an IP RAN network, they don't want, say you have 4,000 cell sites. They don't want 4,000 areas.
And areas are typically configured, right? Yeah, areas are typically configured, so you don't want to configure 4,000 areas.
Yeah, but you create a virtual thing that's on a spoke, on a hub will be visible as a separate area anyways.
That's what we're proposing, so you could...
Right, so basically you are creating, on the hub, you will have the same scaling problem because you are treating each spoke as a separate area. Greg.
AC Lindum again. At least for OSPF, and I think the same for ISIS, it's an IO-bound protocol, and the flooding dwarfs everything else. Everybody thinks it's SPF. That's nonsense. It's not the SPF. It's the flooding. So by this way, you get the isolation for each site. If you do a profile of OSPF, you'll see that, especially in topologies like these, you'll see that the flooding is much more than everything else.
Right, but that's why you'll do NSSA.
I said they don't want 4,000 areas.
Change defaults.
But AC, what he's saying is that whether you configure 4,000 or it creates 4,000, you still have 4,000, right?
I would like to support this gentleman that stub in the the NBMA in the stub area is the same essentially in this proposal, like the 1,000 areas or the 1,000 instances, right?
So if it's NBMA and then if it's in the same area, then the change in one spoke gets flooded everywhere, and that's the problem, right? And if you want to put it in different areas, then it's 4,000 areas which need, a spoke comes in, you need to configure a separate area and then put the spoke in that particular area, which does not suit well for the zero touch hub deployments, right? It's not plug and play.
Les Ginsberg. My question you kind of spoke to this, I think, in the previous slide, but I'm kind of mystified at what it is you want the IETF to standardize. This seems to me to be a solution that a particular vendor might choose to come up with, and in fact, there are solutions that are conceptually similar to this that have been deployed. So what is it that you want the IETF to standardize?
So especially if you take the ring topologies, right? I mean, the two L1, L2 hubs, if you want to deploy the solution, they need to do some procedures which we want it to be,
But this is totally internal to your box. There's nothing that's changing that's going out on the wire. There are no protocol extensions. You're talking about how a particular vendor decides to implement something and what configuration options it offers. I don't understand what we would standardize.
We have to standardize some default behavior, right? Otherwise,
This is Pushpashish here. So the answer to your question is why does it need to be standardized is because there are two L1, L2 hub routers there. They can come from two different vendors. So they need to agree on the procedures.
What is it that they need to agree on? In my reading of the document, I didn't see anything that was defined. If there is, put it in the document.
If they both need to implement the same virtual multi-instance, right? So that's, and they need they need to follow some default behavior, like advertising the hub-to-hub link into the virtual multi-instance and stuff like that. And I think that needs to be standardized.
Jeff has by somewhat analogy, this is somewhat similar to what GROW does for IDR. There are things that are not protocol style changes that are operational behavior style changes. We're really observing in this draft, here is a problem space, here is a way to address it without necessarily changing the protocol by operational practice and a mechanism for providing some sort of shortcuts in terms of configuration to create this sort of thing. Standardizing that set of shortcuts allows more than one vendor to come to the same solution so that if you are attempting to deploy this multi-vendor environment, you can allow more than one vendor to use the same shortcuts for user experience.
This is Uma from Ericsson. I have one clarification question. I read the draft briefly, skimmed through it. You need to clearly describe the hub behavior. What needs to be done.
Okay.
That will clarify a lot of questions here.
Okay.
So I agree with that. Both L1, L2 routers here need to understand, do the same thing. Then
Yes,
only
sir.
this will work.
Yes.
So for that, this draft is necessary, I feel. And another part is the ISS has the RFC for flooding scope RFC.
Yeah, right.
What I heard is that requires upgrade for the spokes. Is that correct?
So you need two nodes to support the flooding scope to be able to use it.
Okay, thanks.
Aaliyah Atlas, just obviously as an individual contributor here. As two things. One is, Les, there's a couple things that need to get, for the ring topology. Sorry, I can't both talk at this time. Look at you. For the ring topology where you have two hubs, one of the things that's happening is both of those hubs are supposed to advertise the links in between them. And one of the questions, and obviously you need to have both hubs doing it or else you don't get bidirectionality. And one of the questions is, how do you identify the other hubs in the topology so you know which links you need to advertise into the virtual instances? So that's one piece of it. I think you end up with the same type of thing for where you want both ends of a dynamic tunnel when you're doing spokes to do the same type of prefix redistribution and be treating that. So that's the cases where if you've got deployments with multiple vendors' boxes, having a standard behavior is useful. Second is on the OSPF areas versus instances. Yeah, if you want to do this internally as a virtual areas without configuration as opposed to virtual instances without configuration, that works fine. You just can't do that in ISIS. Yeah.
All right, not to get into debate because we should take this to the list.
It's always fun, yeah.
Yes. I believe there are existing solutions today that do this, and they do it purely based on appropriate configuration. I'm not saying what you're proposing here is good or bad or better or worse. I'm just saying I don't see anything that needs to be standardized. No disrespect to the other speakers.
AC Linda, I know of IPR that does similar isolation in the routing protocol, where it isolates, uses a similar, where it uses the, how OSPF has a link local database, it puts the scoping of the sites, this IPR, of which I'm one of the authors, puts it in the link local database. So I probably should send that out. You can look at it.
Thank you.
Thank you. So I would really like you to go to IGP group and ask for comments on this, since it's somewhat.
Go to the IGPs.
Yes, so SS. As well, we also discussed what would be the appropriate track for the since described solution.
Yes.
Thank you. Santosh?
Good morning, everyone. I'm audible. Sorry. So good morning, everyone. I'll be presenting bandwidth-based metric FRR.
Could you please stay in the box? Thank you.
So bandwidth-based metric FRR, we have the version 1. We have addressed a couple of comments that we received in the last IETF. Unfortunately, we couldn't publish it in time.
Is that working?
So in IETF 92, Dallas, we presented use cases of this draft and also the interface, how to configure the interface group and what are the parameters required to configure the interface group. And also how to derive the metric from the interface group, right? So based on the bandwidth. So these were the things that were discussed in the IETF 92. So the second part of the draft, which was FRR, which I'll be presenting it today. So why multiple backup FRR? So RFC 5286 LFA doesn't really suggest or doesn't restrict from having a multiple backup. But the thing is, most of the implementation usually have a single backup, and also when you have a backup, a single backup which is being used, and so if primary link goes down, then there are possibilities of backup path getting congested because it is already carrying some other primary traffic. It's also most of the implementation we have seen that whenever you have an ECMP, you don't really have a backup installed because you will be doing a load balancing based on the ECMP itself. Now, LFA or remote LFA doesn't really suggest how to make use of bandwidth to compute the backup paths, and that's exactly what we are trying to address in this draft. So I would like to start with the assumptions and the limitations. The assumptions is that we definitely need the data plane support or data plane changes so that we could support the multiple backup paths. So the first thing is that we are assuming that it should be able to handle the multiple backup paths. Plus, there should be a slight modification, or whenever the primary link goes down, all the backup paths metric or the preferences should be modified when the local repair is triggered. So second is downstream path check must be implemented to avoid any loops. End-to-end bandwidth is not considered in this particular draft. And also single link failure, this draft is assuming that this is only addressing a single link failure. So there have been comments we have received that, to consider multiple link failure, and we'll be addressing that's for the future consideration. Okay, so new FRR configuration along with the interface group, we need a few more parameters like minimum bandwidth and the restore bandwidth. So minimum bandwidth is a configuration which tells about which says that if your group bandwidth falls below the minimum bandwidth, then you should share the you should start sending the traffic or spray the traffic with the primary and the backup paths. So that means it is not. So the group should be able to satisfy the minimum bandwidth. The restore bandwidth is something where if your group bandwidth, interface group bandwidth is greater than this restore bandwidth, then you really don't need a backup. So these are the two configurations we need. And of course, along with this, it should also say that protection is enabled on the primary group. So there are a few preferences that we suggest in the draft. The first preference is, I guess it is well known, that is primary path preference, which is 0x01. And we have a backup preference high, which we have suggested as a value of F100. I'm showing in the slide below. I'll be using this as an example to show how really the backup calculation happens. And also the normal backup path preference, that is FF00. So there are 3 steps to calculate the backup, primary and backup though, when FRR is enabled. So the first step is to go through all the interface groups that are configured and calculate the cumulative bandwidth and the post-fail bandwidth. Now when I say post-fail bandwidth, it is the bandwidth of the interface group available after the highest link bandwidth that goes down. For example, if you have 2 links, or one with 200 and another with 100, so your cumulative bandwidth is 300, whereas post-fail bandwidth is 100. So once all the calculation with respect to cumulative bandwidth and the post-fail bandwidth is done, we enter into the step 2, where we are actually calculating the preference of the primary, or I would say preference or weight. Right, so it's a loop where you are going through all the primary next stops, that is output of SPF and LFA calculation. And when you go through the next stops, the first thing is you get the interface group to which it is attached to. And if you see that if the interface group cumulative bandwidth is greater than the minimum bandwidth configured for that group, then assign the preference as the primary preference, that is 0x01. If not, you need to assign the preference as 0xFF, and that is backup preference normal. So this is the first loop, first pass, where you are assigning or where you are calculating the weights or the preferences of the primary next stop. So just see that in primary, while calculating the primary weights, you will also see that though after LFA calculation you got them as the primary next stop, you still might end up making them as the backup next stop. How do I use the So you might still end up as marking them as the backup next stop in some cases when your cumulative interface bandwidth is not really satisfying the bandwidth.
So I had a question actually about the path preference values. Yeah. Have you, why would those need to be specific values as opposed to just a ordered list of preferences? Yeah, so there is no, this is a suggestions, and also I'm using it as an example. So that is the reason it is there. In the draft also we have suggested this. If you think that, if the group thinks that, that is not really required, it can be anything. So that's fine.
Uma from Ericsson. I don't think it's needed in the draft. It's an internal implementation. You can do so many ways.
Sure. Yeah, we can address that in the next version. So, like I said, even though you have the LFA output has been, the output of the LFA says that this is the primary next stop, we might end up making it as a backup next stop. And also if it, because it's satisfying the, the minimum bandwidth criteria, if that is the case, we increment count, that is number of next stop counts. So this will be used in the next pass when we are calculating the preferences of the backup next stops. So this is a bit messy. Sorry for that. So now we come to the backup calculation. Now we have the primary paths preferences set. Now what we are doing is we first go to the primary groups for each destination. For a particular primary next stop, we go and see if the primary group protection is enabled or not. If protection is enabled, just end the loop and come out of it. If protection is enabled, then you want to go and check whether this primary group really needs a backup or not. So since we are considering a single path single link failure, and also the post fail bandwidth has already been calculated. So the first thing that we do is to see if the post fail bandwidth is satisfying these criteria of restore bandwidth and minimum bandwidth. So if it is satisfying, then there is no need of backup and you can end the loop. If it's not satisfying, then we need to calculate the backup, and this is where the backup calculation comes into picture. So for all backup next stops, you see whether there is a primary count already. Is there any primary next stop preferences? Is there any next stop with the primary preferences already set? If the primary preference is not set, then there is a chance that backup can become the primary. So that is why we check this. If the primary NH count is 0, that means there is a chance of backup becoming a primary. And if the backup group is satisfying the given criteria and not the primary, then we are making the backup as the primary next stops. So this is the place where we change the LFA output, right? So, and also if it is even the backup is not satisfying, then it is taking as backup a preference, so that we can load balance with the primary and the backup in case both primary and backup are not satisfying the bandwidth. So if the primary next stop is already present, then we are actually calculating the backup's preference, whether it should be high preference or the low preference, right? So if the backup is satisfying the bandwidth requirements, then you want to set it as a high preference, and I'll give you an example of how this high preference is really used in the next slide. Whereas if it is not satisfying, then obviously it will take it as a backup preference. So this is the loop, this is the second pass where we are calculating the backup preferences. So since I explained how this algorithm works, or how this these 3 steps works, I wanted to also give an example to show how this really works when local repair happens and when global repair happens. Right. So let us assume this. Let us assume that we have the same setup as described in our draft. We want to reach D1 from R1. You have an IG1 configured and IG2 configured with all symmetric links L1, L2, L3 and L4, L5, L6. So in this case, L1, L2, L3 is the shortest path to reach D1, all having 100 gig links. And L4, L5, L6 are all again, is this the backup path because its metric is 30 with all 100 gig. So the configuration is such that, initially the cumulative bandwidth is 300 gig. Post-fail bandwidth is 200 gig, revert bandwidth is 200 gig, and minimum bandwidth is 200 gig. So the post-fail calculation is, these are the configuration, 200 gig and the 100 gig. So these are the output of the first step calculation, right? So if you see a post LFA, you would get, post SPF, you would get that IG1 or the interface group 1 is the shortest path to D1 because it is having a metric 20 to reach D1, whereas IG2 is having a metric 30 to reach D1. Now IG1 is having a 300 gig bandwidth, so it satisfies all the configured all minimum and the restore bandwidth. So you don't really need the backup here because even if one link goes down, you still have 200 gig, which is satisfying both the restore and the revert bandwidth.
2 minutes.
Yeah, sure. So you really don't need any backup, and that is the reason why you don't have a backup. if one link goes down, this is the local repair time where IGP repair has not been triggered yet. So if one link goes down, this is where the PFE's changes come into picture, or the data plane changes come into picture, where it is modifying the weights of the remaining two next stops, primary next stops preferences. So this is required in the examples ahead, but in this you might not feel it is really required. So post IGP repair, you would see that the IG1 still remains the primary path, because it is metric is 20 and this metric is 30. And post calculation, if you apply the same algorithm, you would see that this particular primary group doesn't satisfy the bandwidth if one more link goes down. So restore and minimum bandwidth. So that is the reason why we have already calculated the backup with a higher preference backup path weights or the preferences, and downloaded it. So that during the local repair, if the L2 link also goes down, you would see that the data plane has marked this primary next stop as FF, and the remaining is F100. So this means the traffic has already started flowing via the backup path, and it's no more taking the primary path. So by doing this, you are actually ensuring that your traffic is not flowing via the lesser or the bandwidth or the links over which the bandwidth is not satisfied, even before the IGP comes into picture. Then IGP comes into picture, and this and the weights are changed because of the bandwidth based metric configuration, and you'll see that IG2 becomes the primary path to reach D1 because it has a 30 as the bandwidth, and IG1 has a 60 as a bandwidth. So that way the calculation goes on, and you'd see that at last you would see that the traffic has been load balanced among a single link on IG1 and single link on IG2, though their metric is completely different, but we are using it as an ECMP. Due to shortage of time, I would have to end here. Any questions? We can take it on the list if.
A few comments. So, with regards to state on the CMP, I'm personally aware of at least two implementations which give you enough to say whether you want to use eCMP as part of your LFR or not. So.
Okay, yeah, I understand that. I mean, I was talking about few vendors where we saw that, if there is a eCMP, you don't install the backup.
Next comment, please make sure the values are not normative values. They are suggested values, right?
Yeah, sure.
And I would really like to see some activity on the list and some comments from people who are actually using it, operators. Do you think it's useful? And so please initiate discussion mailing list.
Sure, I'll do that. Thanks a lot.
So since we ran out of time in the previous meeting on discussion or presentation from design team on young models, we've got 15 minutes to continue.
So we didn't have anything specific that we wanted to cover. We sort of felt like we talked enough at the last meeting. And so this is an opportunity for folks to ask questions. If we don't have questions, either we can pull up the open issues or we can get back on schedule, and that's the group's call. Did you want to take minutes for this?
Yeah.
You can just So, are we going back on schedule, or do you want us to throw up the open issues? Your call.
Let's spend a few minutes on open issues.
Do you mind bringing up the deck from the last? So, as we mentioned before, everything we're doing is captured on the repository that's been published, so that the list we're going to talk about here is straight lifted from there. It's a file called open plus, no, what is it? Issues plus something else, I don't remember. That doesn't look like the issues. So go to the end.
Oops. Do you want to go to last slide?
Yeah. Yes, please. Oh, second 27.
So actually, that's a fine place to start. Where are we going next? We are still working on the device model. We expect to do some more changes on that. Once we get a little more maturity, hopefully by the next IETF, we'll say, okay, the design team is ready. Let's throw it over and for broader input. Of course, if you feel like making a comment now, just send it to the list. We also are going to definitely finalize an op state recommendation. Right now, we have agreement on, as I said before, we have agreement on requirements, not on a specific solution. We may or may not get agreement on a solution recommendation. That really will end up more with NetMod than here, but it definitely will impact all of our modules, our models. In particular, lots of folks have refactored to do the whole op state thing. And if NetMod says, hey, we have a better way of doing it, or alternate way of doing it, we're going to have to all refactor again. So that's actually a pretty important discussion centered in NetMod. And as I also said on the first day, we haven't figured quite out other conventions or BCP of New Yang features, so that's coming. You want to go through the open issues? I'm being mean.
No, so just back to the op state thing, in case everyone's ignoring this because they don't really care about NetConf or whatever, it is rather important to the effect on models, right? So if you've ever written a model, or it's one of the solutions replicates things a lot, or we could have a verb that says get the different version, right? You might want to familiarize yourself with that. It would be good to have extra people in there on that decision.
I think I can characterize. There's that issue whether there's a verb to get the intended state or the actual state. That's the config. But there's also the config false data. And another issue is whether that goes in a separate tree or if it resides in the same tree in the leaves with the config data. And I think the direction we have is to put it all in one tree and one root. That's the direction. You should get involved with the discussion then, Jeff. Okay. But
we should say that's the direction it's going.
That's the direction of the design team. We've Yeah.
So you're going to see disagreement here.
Yes.
We definitely have agreement on the requirements.
It's true that that's what we put down. Yes.
In the past.
Yes.
I don't like it.
You don't like it. Okay. Well, and this will have an impact on all the models because typically right now the models are what we've had in routers, or as they're called in Netcom, network devices. You have the show commands and you have the config commands, so it's completely separate trees. Now, there's a question where to put these things like non-config data too, like counters and FSM states and things like that.
So Jeff, the big consideration really isn't how you mix it, it's what the data is going to come out like when you actually are trying to retrieve it for operational purposes, especially stuff that's large bulk data. The issue with intermixing config and operational state is that you are cluttering up what you're trying to fetch for operational state. And in some cases, if you only have a little bit of config, it's not a big deal. But if you have 80% of your config for a given node, and then 3 of those nodes is operational state, you're getting a lot of extra clutter from there. So that's part of the motivation to want to separate it. Of course, the second half of that is if you completely separate it and you require some piece of that configuration state for context, your choice really is either to make the user go grab that as well or to copy the data. So I agree, it's not an easy win solution either direction. My specific recommendation is write this for consumption mostly by devices. Make sure that enough context is available so you don't have to cross-reference. One of the things that I think is a item you're going to want to spend a lot of attention on that I don't think you've gotten to yet is cross-correlating data. Being able to say, I have a bit of state here, operational state especially, that is going to be a cross-reference, usually leaf ref or something else like that, to another module. So for example, tunnels cross-referencing to interfaces, LSP IDs, link states, links into the topology model and vice versa. This sort of ability to cross-pollinate between the different modules is something that Yang does and has potential to do very well that we just simply could not do in SNMP. It's not something that a standalone application really needs. It's really for those systems that are trying to do deep analysis between systems. And where this sort of changes the game is we stop trying to troubleshoot individual protocols. We actually start trying to provide the plumbing to allow the system to be troubleshooted as a whole.
Yeah, I think you hit some interesting points there. On that last one where you say Yang is good about being able to provide these pointers, I would say, and then you went on to talk about SNMP, and you're right, in the context of SNMP, it's good. In context of normal programming languages, I wouldn't go that far. It's actually quite cumbersome. Think about how we have to do essentially linked lists. It's sort of ugly. So we actually have spent a lot of time talking about the pointer problem and how to deal with it in the general case, and then how to deal with it with what we've done so far. So maybe we can do better about thinking about how to deal with it in the general case. But frankly, what we did is we said, hey, NetMod guys, how do you deal with it in the general case? And they said, we do X, Y, Z. We said, okay, we'll follow you.
So I'm going to excuse the NetMod guys on this. They have spent a lot of time modeling configuration. That's really where their head's been the last few years. That's where IETF has been spending its entire time, throughout Yang Fever in the last year plus. The operational state is really the cool stuff. The configuration is going to take a lot of work to get right the first time. But the operational state's where we end up living in the thing once it's done.
So if you have suggestions on how you think we should be doing pointers, and if we're doing it, if you want to do it, we have a couple of very limited but important cases already in the device model. So if you like what we're doing there and you want us to continue doing it that way, great. If you think what we're doing there isn't the right way to do it, we want to hear about that now.
So quite frankly, I'm waiting one more cycle for the OpenConfig guys to have a little bit more of their fight, for the operational stuff inside of NetMod first, because that's going to churn the entire IETF. And honestly, I'd rather fight that specific battle before trying to get you to move things around. Really, the advice I'd give you for the work you're doing today is the same that I'm giving everybody else when they're working on their operational, their config state. Put it all in right now. Make it structured in a way that you think actually solves the use case. Not cluttering the data too much. We will have to move it around. We will be wrong. We will have to refactor. And the OpenConfig operational state thing is going to be the main motivation for that to happen. Don't worry about that today. You have plenty of work to get done before that. But once that work is then settled out, you'll be right in the middle of it.
So I think it would be really valuable if instead of waiting for the next iteration, you actually participate and provide your very valuable comments, so we don't need to go twice or same mistakes.
Yeah, and when I was saying I didn't like it was really about this whole thing with I guess config true, right? Not config false. And this is the thing that I thought was going to cause a lot of churn. I wasn't aware there was even an issue with the operational state.
No, I think this is what he's talking about.
This is exactly what
that's actually what I was going to say is which operational state are you talking about?
Exactly. and so to your point, Jeff, I am participating in watching behind the scenes, but mostly there's some amount of religion that's going on here. Opinion is being provided, but anybody who's been doing work with the OpenConfig group is aware that they are strongly opinionated and they need to sort of settle out amongst themselves what they think is going on first. Once they've actually managed to do that among the NetMod group, which the reason why it's important for this to happen in NetMod first is some of the things they're asking for are not strictly simple organizational things which the architecture team can deal with today. some of these things are protocol impacting in terms of what that means and be able to do with the operational state. So the arrangement would change whether it's no changes to protocol versus changes to protocol.
Yeah, and to be even a little more precise, the discussion is whether to address this problem of having intended versus applied, and whether to address that through model conventions or through netmod protocol transaction changes.
Yes.
And within the design team, we've had a lot of discussions on this, and we definitely we've actually come to agreement that the requirements that lead us to having applied operational state is a good thing.
Yes.
What we haven't agreed on is whether or not encoding that into a URL, well, I think there's URL, a path, excuse me, as well, I should say URI, but whatever, a path, and having it reflected in each and every model is the right way to do it. We don't have agreement on that.
You don't have agreement, and you're probably not going to have agreement until that piece is shaken out. Because really it's going to be the fundamental back end of what they're doing is probably going to really set what you're thinking long term. And that's why I'm going to suggest don't worry about the pre-existing, the pre-optimization of this stuff. The important thing is, can you actually do a query, get all the related state, not contaminate it too much with having to have duplicate configuration state, and actually make the applications that need to consume this stuff happy. As I mentioned at the previous session, the structure you've come up with is a bit CLI-like. It makes people who are familiar with existing devices very happy, and I think that some of those things are effectively just noise. It doesn't hurt anything really, but it does, I think, have some interesting longer-term repercussions.
Yeah. And I bristle a little bit when you say it's CLI-like.
So I also sort of didn't like that. I mean,
So actually, we're going to need to end this session. If Igor has a short question, I just wanted to stop this to let Igor ask his question because he's been waiting in line, and then we need to move to the NCAP design team. So, go ahead.
Igor Briskin, Ottawa. I have a question to AC. Basically, where do you see the problem with totally separating config and upstate data stores?
The requirement from OpenConfig is to have a programming model with predictable paths, and rather than having separate ones, so they're going to want to see what's active, the active config plus the config false, and if they're going to, if you have a convention with a predictable path, you can find it if it's all in the same leaves, the related stuff. That's basically the requirement.
But if you have prefixes, right? So basically to the path.
Either please take it as a list, okay?
Okay.
About that. Larry? Or sorry. Eric?
Go grab this. Drive it from there?
Yes, definitely.
Okay. So the design team's document has become a working group document since the last time. So we can go to the next slide. So with this, the actual design team that put together this initial cut is actually over with. Because we're available to answer questions and help with edits to the document, but we're not having any design team discussions anymore. But next. So what I wanted to cover here is what have we actually done, what changes have been applied to the document, and summarize those since Dallas, and something about what we need to do. And I realized that list in the slides is a bit short. I was going over some more comments now this morning. There's some outstanding comments from the routing directorate review, and some of those are on this slide. And then there's some sort of larger issues that have shown up in a couple of different contexts that I want to touch on as well. So next. So these are a bit wordy because it's actually text from the document, but I don't know if it's best for people to read them, but it's a bunch of clarifications and feedback on the document. The first one relates to the scope question. So there's been comments that, you know, there are different classes of encapsulations, like SFC might be different than NVO3, for instance, and hence we should sort of subset the different considerations. And instead of trying to figure out how to split that, actually added some wording saying, yeah, go read and understand these things, and then you might decide that my type of encapsulation, because of the way it's applied, right, the way it sits in the stack and in the network, we don't run into these particular things, right? So that's an important thing to keep in mind. But next one. There's some editorial clarifications around the next header discussion. And then there was some mentioning that we added about the MPLS first nibble that shows up in the next header context. And it has references to, I forget which document that actually has more detail about this. And we also mentioned that, based on some comments from Stuart Bryant, that the technique in MPLS or the architectural approach where the label is really an index to a table of instructions, or can be viewed as such, right? The label itself doesn't necessarily have semantics. It's more like the semantics are defined outside of it through the control plane, whatever, is something that people might want to consider because it actually can buy you more flexibility. So there's some text around that we've added to the document. Next. In the OEM section, we had something about how can you tell whether a packet is an OEM frame that should not be sent to the end stations. And the document had two different choices earlier, and based on some feedback we got, it seemed like actually having a bit that says this is an OEM frame that you might end up decapsulating, but it shouldn't actually go to the intended recipient because its purpose is just to measure whatever you were doing towards the decapsulator. There were some changes in the security section where it previously was talking about IPsec as one of the ways you might want to optionally secure the header and or payload that you're encapsulating. And that was reworded to say, well, you might consider using DTLS there as well. There's some architectural comments that came up regarding header. So there's been some IP and IP encapsulation protocols where people have said, well, when you go and encapsulate this IPv6 header, well, should you take some of the IPv6 extension headers, options, whatever, and copy them from the inner header to the outer header? And so based on those comments, we added something saying, yeah, this is something that's been done before. It's not clear whether that's a good idea in general, because it's a bit hard. In a simple world where there's only IP and IP encapsulation, some of that stuff might make sense. But when you end up with these deep nested encapsulations, you might have some layer 2 headers in the middle, right? Why would you want to do that? Is this something that's important to try to do that type of migrating out of headers? We have specific cases where we do this, like with DSCP, right? Where you might want to say, I want to, subject to configuration, I might want to label the outer packet based on how the inner packet was labeled, or some other determination of its diff serve code point. But it doesn't say that you should go do something new and exciting here. There was also, the second bullet, there was actually also an interesting observation, but I don't think it changes that much. But it's basically, there's some cases when historically we've said, we're going to do this thing as a new protocol. It's going to have its own separate header. And in other cases we said, well, no, we just add an option to an existing header. And I think that some of the things we see today with sort of splitting across different protocols, different NCAPS protocols in different working groups. We've done that at that sort of organizational level. But there might still be cases when you say, well, this thing, is it an extension using the extension mechanisms, or do I just say, I have another header here that does this new whatever, fancy security, whatever, right? And people might want to look at that and say, okay, I haven't seen a case where this would change anything we do, but I think it's actually good to capture that architectural observation. Next. Oh, no, I'll go back. You went ahead of me. So there's some text, or was some text about unconstrained TLVs and how this relates to hardware friendliness. So that text has been reworded slightly, but there's still some outstanding comments. So one of the, Jamal made a comment saying, well, should I paraphrase it as, why can't just those hardware guys get to work and just build hardware that can parse TLVs? And I think that's a good discussion to have, because what's in here in this section today that basically says, don't make it too hard for hardware by having lots of different variants with different TLVs that can happen in arbitrary order, and the hardware needs to go parse that. That sort of that level of statement was something that the design team felt comfortable with. It's up to the working group to decide what the working group feels comfortable with, but people might want to go look at that wording in detail that's in the hardware friendly section. But at least we try to make it a bit more clear what we meant here. There's also some clarifications about checksums, just saying, yeah, the cases when you might want to have some protection against bidders that cover your encapsulation header, that might have, bitmaps, VNIs, whatever might be in there. In some cases, you could do that by encapsulating that header plus everything. Checksumming that header plus everything beyond it. But the wording wasn't clear, saying that, yeah, you might still want to consider just, if you don't do that, you might still want to do it for the header itself. There's some wording because people pointed out that, well, this stuff have some similarities with other cases when people do UDP NCAPs that might be more apps driven or whatever. So I just added some words about that. And then some reference tweaks. So that was what we've done, plus editorial fixes, minor editorial fixes. That's what we've done as part of making this into a working group document. So next. There's some things we have to fix. The most important one is this one. So the document, I put in a hook there to see, does anybody actually read this document? So Jamal actually read the document and he found this piece of text. It was also there because to point out that, well, we're not expecting to have any definitions of must and should in this document, because wasn't intended to have any requirement. It was intended to actually have, considerations, things we've learned or whatever, things to consider. Next. So there's some outstanding things from Jamal's routing directorate review. And one of the things he asked for was some more explanations relating to this sort of my way of describing what MPLS labels do, that they're an index into a table. So I have to go dig that up. The other thing he suggested was, getting more concrete statements out of the different sections to be sort of make it easier for the reader to figure out what's the conclusion here. And I didn't realize that he actually read the version that didn't have the summary. So one of the things that it would make sense for everybody in the working group to go look at is, are these summaries, there's one in most sections, right? That's just a few bullets. Are they actually helpful? Or is that sort of concrete enough in terms of advice or considerations? And they actually are in the slide deck, and I wasn't planning on going over that today, but they're in the slide deck so if you can just pull that up and look at the last, 11 slides or something, you can see, is this useful, right? There were some other things about references to quiet periods, how to go dig something up and tweak the document. Next. So there still is this lingering thing, and if the working group, if I would like to have more people weigh in on this thing, but the issue is about the scope, right? Is the scope clear enough, and the intent of this document? Because people have asked, several people have asked, well, could you make it more clear what sort of should apply to my protocol? What do I need to worry about? And if that's still sort of is a lingering thing there, we need to figure out a way of capturing that better. But right now, there's just this, please read and understand it, and then you decide that I don't need to care about MPU or whatever. Right? So that's the current state of things. I don't see people jumping to the mic. So next. MPLS. So this is one of the things that was brought up in Dallas, saying that as the working group picks this up, maybe we want to capture more things that are relevant to MPLS as a transport. So what we have in summary in this document today is it talks about entropy labels as a way of doing entropy when you have an encapsulation that wants that. It talks about the first nibble issue by and having references to documents that have that. I don't remember if the text is has more recommendations saying, don't touch the first nibble or whatever. And this index thing, right? That's, I think, the essence of what it says about MPLS. And there might be other things that, that people that are experts in MPLS say, well, if I want to have people use MPLS as a transport for new NCAPs, what things should they know that they might not know, that are not obvious, right? So I'm looking to you guys in the room and in the virtual room to say, if you want more things here, basically send text, right? We can figure out how to get it into the document. But no one jumping to the mic? Next. So people have also asked for, make it be more sort of direct, right? This is part of what Jamal asked, and it's shown up elsewhere. And if we have a few minutes, I can page through the last 11 slides as well. I don't know what time do you have?
22 minutes.
Oh, okay. That way people don't have to reread the whole document. So next. So that's sort of where we're at today. So I'm looking for more comments on this document. And this slide, no. Go ahead.
Jeff Haas, I have one question about the design team's discussion about those magic OAM packets that may never make it to the host.
Okay.
Did anything ever come up in the discussion about privacy considerations? Because that's effectively a way of having magic traffic that is privacy impacting, but the user may not be able to even tell.
That hasn't been discussed, and I'm not sure I understand what the concern is.
The concern is if you're worried that somebody may be subverting the link or doing something else to monitor you. You'll see our film discussion from this Sunday as an example of random things of concern. If you have the mechanism completely avoids actually getting to end host, the end users themselves can't tell that mechanisms that are being used to monitor their tunnels may be in play. So if you're setting this up as something that you want, that's a happy thing. If some three-letter agency happens to be inserting these types of things for you, you may care about that a little bit more.
Okay, I think I understand. Yeah. We'll go ponder that and see.
Okay, so has not been part of your discussion. Thank you.
Yeah. Okay. So next slide. So these are just a summary slides, so we can go through these things quickly, but just to try to trigger see if it triggers some discussions. I'm not going to read them. Just page through them gradually. See if people jump up. So the first one is about entropy, where there's 2 bullets. About MPLS and the possibility of using flow ID in addition to UDP source port. Next. And we have these things which we need to figure out what to do. They're sort of non-summaries. They're questions more than anything else, right? So for next header, it's like, okay, should we do something that's more common across different end caps? There's 3 different places where an end cap needs to deal with the next header, next protocol indications. It's identifying what it carries, it's how it is identified as being in the packet, and it's if you have some nesting where you have multiple headers, how do they point at each other? And the feedback I've gotten so far is that this is probably not worthwhile. We will just let people do their own thing, and some people might use Ethernet types, some people might use IP protocols, some people might define their own. Yes.
David Black, can you go back to the entropy slide quickly? I've got a comment here. I don't think this one's yours. I think it's my headache wearing my transport hat. Simply an observation, which has been seen a number of times before, that if you use the UDP source port for entropy, your headers are non-reversible. And that has some implications for other things. For example, ICMP is going to get black hole if you generate it. But I think those are mostly transport issues that can just maybe a word or two here. But
they don't actually get black hole, but they get delivered to they get sprayed across a large number of UDP destination ports, potentially, depending upon the implementation, right? Right. They go back to the added the header that has the outer IP address on them.
And you hope that ingress remembered what it was doing, hoping other things. It
just needs to have a wildcard match, right?
There are some second order issues, and that the UDP, as you said, the UDP ports. If you port swap the UDP ports, something strange happens. But that's all that needs to be said here.
Yes. Okay. I'll try to remember that. Or if someone takes notes, that level of detail, I will add something to the document. UDP source port reversal. Okay. Yes. So I think the sensible thing to do with this particular summary is, or non-summary, is just to remove it. And I don't think that there's much of a summary left in that section, because it just points out here are the different choices for having next headers. Next. There's something about MTU and path MTU and fragmentation in the document. So the summary is basically, in some deployments, you might not have issues because you assume that the underlay is well managed so that your packets fit. But even in those cases, you might want to be able to pick up ICMP errors that result if that wasn't the case, if something is misconfigured. And also that we have cases when these encapsulations get deployed outside of their initial context, in which case they might need to be able to deal with different MTUs in the underlay. And this is similar, this last observation also occurs in the security context, right? You might go outside of the initial context and you need different things. Next. There's the OEM thing we talked about with a bit, and also that you need extensibility for OEM, because we don't necessarily know what in-band, out-of-band OEM people might want in the future. People have talked about flexibility in terms of doing hashing of packets, and if we want to have OEM packets that can travel the same path as a chosen, TCP flow, whatever it might be, right? Then we need to place some constraints on how that hashing is done, so that that OEM packet doesn't, because of some implementation, having included additional fields, whatever, doesn't actually end up traveling a different path.
Greg Mirsky, Ericsson. Yes, I think that requirement of in-band OEM, guaranteeing in-band OEM is important one. Mm-hmm. At least it has to be set forth explicitly. terms of these guarantees that MPLS, for example, does have it. So if we have MPLS encapsulation and use entropy label, then we effectively can guarantee it.
Yes. But it's come up in other cases when people might say, well, I think even Radio suggested this, that, well, no, but in Trill I can hash on anything I want, right? And
then you're on your own.
And like, well, then I don't know how I can ensure that
Right.
the OEM packets go to the same
if you
place.
hash on your whenever you want, then
You
all
include,
bets are off.
you include the OEM bit in the hash, right? Then things will actually not work the way it's intended. And there's a question in this section as well, and I think that's part of the larger OEM discussion. And so there's some Greg and folks have been pushing for things in beer to have some OEM discussion there. But to what extent, if we're going to have some error reporting related to these encapsulations, does it make sense to define that in one place as opposed to having the same way we have ICMP for IP, right? As opposed to saying, no, each encapsulation might have some separate error message scheme, whatever. And I think I'll leave that one in for the time being, but see how things actually evolve. Next. Security needs extensibility, or implies the need for extensibility. I don't think we're going to require security, but it's up to the individual working groups and how they sort of manage to convince the ISG at the end of the day, whether they have mandatory security of what form, but at least you need to have the flexibility of adding some more fields in a header for security purposes. Right? Or have some way of carrying IPsec, DTLS, whatever it might be. And the last bullet is, your protocol might go places you never intended. Be aware. Next. QS is just a reference saying this is well defined for DHCP, tunnels. Next. Congestion is also pieces that you can actually reuse. And the transport area working group might come up with a better document that we can reference here right now. The best text for this lives in MPLS over UDP, I believe, right? That talks about when you would and wouldn't do this. And maybe Dave will say that they're working on this. Or are you planning on lifting that text and putting it somewhere else as opposed to duplicating it to multiple documents? Or
no, I'm going to issue a warning on that text. This is David Black about the scars and putting that text together. That text is very service provider, network operator, infrastructure tunnel centric. If you're doing something like MPLS that's used like MPLS, that text is wonderful. If you're not, it gets really interesting. You might want to come to the discussion of the GRE and UDP draft in the Transport Area Working Group, where we're hitting exactly this issue and confusion.
Okay. So we might need to, sounds like we need to update this reference at least at some point in time. So. But the plan is not to have the detailed text in this document. It's just saying, look over there, and over there might change. There's also some, circuit breaker thing that we have right now have a loose reference to because it's not clear how that will evolve. But that's also just a pointer saying, go look over there. Next. Header protection, you might need some checksum CRC. Yeah, I don't think there's anything particular in either, but this is what we put for the summary. Next. Oh.
Yeah, probably good enough, David, but just the design work you have to go through if you don't check some of the V6 header and you're using UDP is not for the novice. I'll simply stop there.
Yeah. Okay. Extensibility, I think the important one that people should keep in mind is the second bullet here, which is that we have some evidence that if your protocol has this great extensibility mechanism, but no one actually uses it for anything important, it will actually not be usable, right? Because people will make implementation shortcuts, people will build middle boxes that assume that stuff is never there, And when you then go to try to use it, you find that it's useless. We've seen this in slightly different contexts with different protocols over the decades. So I think it was useful to lift that out and make sure that people think about that. Next. So this is the short summary, and it's in this text. This is actually summarized of what the bullets are in the hardware-friendly one. It's out of this type of logic that the unconstrained TLVs is actually hard for hardware to deal with because of the number of basically combinations of bit patterns they have to deal with. And hardware can deal with limited number of combinations of bit patterns by just doing things in parallel. But if you have too many, it just ends up being costly. So it depends what parts of the header the hardware actually needs to parse as well, which might be different depending upon what context your encapsulation is deployed in. And is this something that's done by vSwitches leveraging NIC offload, or is it something that's done by forwarding devices that are built slightly differently? Next. And then there's a separate section that we lifted out that basically says, well, that has a fair bit of detail about NIC offload. The summary there is that, so if you're using a vSwitch, you would want to use the NIC offload capabilities. Well, that places some constraints. One of them is that it's actually easier for the NIC offload to do full checksums than some new header-only checksum, because they already have support for full checksums. But the other one is that they have this segment offload capability, which means they can replicate headers and spew out multiple of them. But if you put like some sequence number that must be incremented in every packet, you can't use those types of capabilities, whether that sequence number is for OEM purposes, security purposes, whatever. So that's something for people to be aware of. I think that was, oh yeah, another non-summary about middle boxes. But be aware that if your protocols are successful, you will see middle boxes appear, right? That will parse your headers. So that's just something that seems to be a fact of life. And those things might be helpful sort of firewalls. People have talked about NVO3 firewalls that know how to look at BNI IDs and figure out these packets shouldn't go there, right? But you have to make sure that when you're thinking about extensibility, keep this thing in mind. Next. I think that was that the last one? Yep. So that's sort of these bullets. So if you have other concerns or things that you see that is not correct with these things, I'm all ears for tweaking the document. And I, as all other editors in the IETF, appreciate if you send text, as opposed to this thing is hard to understand. Well, suggest something that's easier to understand. Okay, thank you.
A few comments. Since it's a working group document, I would really like working group new in caps, new protocols to really read it and try to understand when to do new protocol, when try to introduce new headers, so especially NVO3 and SFC would be really great if you populate content within those groups. I would really like Aliyah to look into how we interact with transport area, because it has direct relationship with what they do.
Aliyah, the Transport Area Working Group talked about this before it was adopted to go over overview, and probably the thing to do is to send the Transport Area Working Group a note indicating that it's been adopted here, and when it does come up for Working Group last call, to spread that as well.
Okay. Thank you.
Yeah.
Okay. Thank you, everybody, and see you in Japan. Goodbye. Thank you. We're going to have a look at work.
Yes, please. It's like
actually
yeah, convert and USB.
Yeah, reasonably.